I come because I like to learn about what is going on in the industry. I like to hear from the contractors, especially because being an engineer, sometimes it's good to learn from the contractors what innovations they're coming up with, and obviously to meet with other folks and see what they're working on.
This conference is probably the most important event during the calendar year, so you cannot miss it. Because here you can meet a lot of people, contractor, supplier, competitors. So as I said, it's the most important event in the calendar for foundation business, and it's too important to don't be here, let's say.
We come because we get a lot of exposure to people who use our equipment. Camaraderie, a lot of camaraderie. Even with our competitors, we come out and we rub shoulders. Everybody knows everybody. It's just one big happy family.
Well, it depends on whether or not you want to continue learning. If you got a desire to continue to learn, then you need to be at DFI.
The good thing about this conference, you can meet a lot of people over and over, so you can make a very good connection with the industrial people.
Networking's huge. There's so many people here, just from different parts of the country and the state and the world even, and just seeing what processes they're using and their design methods and their equipment, and just really a lot of exposure, and also getting connected with those people for potentially future work, future jobs.
Come join us if you're interested in anything in this industry. This is the place to be. This is it.
Good evening, everyone. This is Sai Sindhu from DFI India office. I welcome you all to DFI India Groundwork 2023 series, session 5. So before we start the session, there are a few instructions. Recording of this webinar is prohibited. Participation certificates for student attendees will be emailed in approximately 2 weeks. Online webinar recording will be available on DFI of India YouTube channel in approximately 2 weeks. So you can ask your questions for the panelists anytime during the session in the Ask Your Question box as displayed on your screens. So without any further delay, now I would like to introduce today's session moderator, Dr. N. Kumar Pitchumani. Dr. N. Kumar Pitchumani holds 30 years of experience in the field of geotechnical engineering, including teaching and as a practitioner. He has been responsible for various projects involving ground improvement of soft clays, reclamation fills, and design of underground structure for metro projects. He is presently involved with Chennai Metro, Kolkata Metro, and Patna Metro. Dr. Pitchumani obtained his bachelor's degree in civil engineering in the year 1987 from Bombay University, and later obtained his master's and doctoral degree from IIT Kanpur in 1989 and 1992 respectively. We heartily welcome you, sir. Now I request you to kindly take the session forward. Thank you.
Thank you, Sindhu. Good evening, everyone. So it's a great thing to be here. So let me first talk about what is going to happen. There are more than 590 registrations from 20 countries for this session here. Today we have, how we are going to go about is, we will introduce the panelists. As you know, we have a very interesting session on underground metros, what challenges are faced. So we'll be having 2 panelists, which I'll be introducing first. Then the theme discussion, the main topic is challenges of working at an underground metro site. So that is our main focus today. We'll be asking questions to the panelists. Not we doesn't mean that it's only me, it's all of us. So I would encourage all of you to participate to the full. I may start the session initially with 1 or 2 questions, but I look forward for active participation from all of you. So please post your questions on the chat, which I will take it up with the panelists. Then we'll have the closing remarks by me on this session of today. And then upcoming DFI events will be presented to you. So we have with us 2 great people. First one is Mr. Palwinder Singh. He is the project manager for L&T. He is a graduate from Thapar Institute of Engineering and Technology, Patiala, and he did his EMBA from SP Jain in Mumbai. And he has around 28 years of experience, predominantly into tunneling, all types of tunneling he has done, bored tunnels, NATM, cut and cover. We'll look into all these terms as we'll ask him questions. What is the difference between NATM? All these questions we'll pose to him. But as of now, he has got experience in all this. And prior to this, he has been in Hydel projects also. So probably in the Himalayas, I should presume. So he is presently the project manager for L&T Tech JV package for Mumbai Metro Line 3. Welcome, Palwinder Singh. It's a pleasure to have you here.
Thank you, sir.
Right. Next, we have Mr. Jalam Srinivas. He is an associate director at AECOM. He is from the design side. Palwinder Singh is from the construction side. So we have a combination of design and construction over here. So Srinivas is a civil engineer, and he did his MTech from IIT Bombay. And he has got 28 years of experience in tunneling, predominantly all these types of tunnels, bored tunnels, NATM, and cut and cover. And he's been in the underground metro systems. He was in Chennai Metro. Now he is in Mumbai Metro. He is with AECOM. So I welcome both of you for today's panel discussions. The topic being underground metro construction. What are the challenges we are going to face? So welcome to you, and audience, welcome to you all. And as I said, I would expect this to be two-way and expect questions from you. So let's get starting. Let's get started. So I will pose a few basic questions. So Mr. Srinivas, could you tell us what this underground metro is all about? How do you go about it? What is this underground metro? How is it different from an elevated metro? So Srinivas.
Sir, the underground metro, basically we cut open the womb of the cities and then we pass through underneath the buildings, underneath whatnot, every structures, you name it, we pass through that. Either it Mumbai or any metropolitan city for that matter. Because when we say metro, this is mostly for mass transport people, mass rapid. So mass rapid usually happens presumably in metro cities. And most of the cities in Indian cities or even overseas, they're congested, and so of the space constraint, usually elevated is ideal. But then again, with that being said, when there are constraints and the only option is either go vertically up or go vertically down. So usually underground is one such option where we go vertically down, either by means of various tunneling techniques. It's not just one. When I say tunneling techniques, we have various types and various different options to explore based on that particular location, that particular site conditions, sir. So as rightly said, bored tunnels, NATM tunnel, all these terms comes into that as a part of it.
Yes, thank you, Srinivas. Palwinder ji, now you have a tunnel and a station. Could you explain how these are and what are these for? There are a lot of students attending this. There are a lot of people from the practical side attending this, so that everybody understands a common terminology. What is a station? What is a tunnel? How do you explain that?
Yes, sir. Srinivas sir has already explained that whenever we cannot go above ground because of the space constraints, so we have to go down. So that means we are working underground. So whenever we are working underground, like any other metro, there will be definitely stations where the people will come in the train and they will go down from the train. So typically the stations are located at approximate distance of around 1 kilometer. If it is a standard norm, if you see in Delhi, normally around typically 1 kilometer plus minus something here and there. And in between, because we are under the ground, so we have to connect the station. So these are basically through the tunnels. So there are normally two lines in across world in metro. So one line is called up line, second line is called down line. Up line means train will go towards one side, down line means the train has to come back. Then to make this tunnel, mostly in underground metros, the machines are used which are called tunnel boring machines to create the tunnel. And also sometimes wherever the scope is less or there are some constraint to make tunnel where TBM cannot be lowered or TBM cannot be put into operation. We are also using the method called NATM. Actually, NATM is a supporting mechanism. The technical name is drilling and blasting. So we also make tunnels when they are shorter in length or where it is not possible to launch TBM with the help of drilling and blasting. So normally in a metro we have two kind of tunnel. One is TBM board. Second is tunnel by drilling and blasting.
Great. Thank you. Srinivas, can you tell me what this TBM is all about? We hear this TBM everywhere. Can you briefly explain in layman's term what a TBM is?
Sir, TBM is a advanced machinery. It's a machine, before we talk about tunneling and all. On a paper, we draw some sketches, some lines. Okay, this metro line starts at this point, it ends at this point. These are just lines on a paper traversing through the buildings, through the rivers, underneath the rivers. It's on a paper only. But when we convert it into reality, these lines to convert to reality, we use a kind of machinery, So these machines, so-called tunnel boring machines, with the latest technology, they are advanced machines, so that they'll drive through these underground, and then to expedite the process underneath the buildings. We need to ensure that the civilians' day-to-day life should not be impacted because of our tunnels. And then the surrounding structures, the utilities, the rivers, canals, whatnot, everything, structures to be protected without, even people might not know what we are doing underneath. So to have that kind of these thing and to progress with the works, what we needed to convert into reality, what was designed or aligned on the paper. So we use these tunnel boring machines, and these tunnel boring machines are of various sizes, are available in different vendors are there in the market. So they are of different sizes. There are 10 meters dia, depending on even nowadays irrigation tunnels are there bigger dia. So for metros, typically in India we go with 5.8 meters. So these tunnels, these 5.8 meter excavation, it's a tube basically. It's a tube. We lay the tube in the ground by making excavation using the machines, and the train travels through these tubes. And these tubes are connected to the stations, wherein when the train reaches the station, people will alight or board that, and then again the train passes through the tube to the next station. So this goes. So this tube, particularly the tube part of it, is driven by the TBM, so-called tunnel boring machine. There are various types and various kinds of machines depending on soil strata and all this stuff. So, but at a high level, it's a TBM which is catered for all the versatile needs of the ground conditions nowadays with the latest techniques. So primarily to have a balance strike between the progress, to strike a balance on the safety of the surrounding environment, building structures, and then settlements of these soil settlements, to avoid any soil settlements. Predominantly, the machine helps us in doing that. Otherwise, digging manually in the good old 18th century, it was done manually. Yes, the Britishers, they have done it manually, but it took ages to finish it. And then they were not durable enough, in fact.
Right. Okay.
So this is in a nutshell, sir.
Nice. Palwinder ji, the TBM as such is a huge equipment. It's a huge paraphernalia, and so how is the whole thing taken down, and how is it? How is the tunneling started off?
Yes, sir, you are right. If you see TBM, the length of a TBM is around 100 meter approximately. If you buy any TBM, whether it is rock TBM or soil TBM, the length is around 100 meter. And also it is also weighing from 300 ton to 400 ton, depending upon the choice of the machine, what kind of machine we are dealing with. Sir, ideally, if someone asks me how to lower it, so I will prefer a shaft of around 100 meter. Now, normally TBMs are launched from a station. So if you see metro stations, the length is varying from 250 to 300 meters. So normally TBMs are launched from the one side of a station. So ideal, if somebody asks me, I will ask for a shaft of around 60 to 70 meters. Then I can lower the machine at one go, and then we can launch the machine from the station to, as Mr. Rao has told, which will start building the tube. So when, sir, here I want to add that TBM is a machine which will not only excavate, it will excavate the rock or soil, it will take out the material. Then we have precast segment rings, it will do the erection of precast segment rings. It will also do the grouting of the segment rings, so that when the machine is moving forward, behind the full tube is ready. Nothing is to be done after that. So launching mean ideal length is 70 meter, but there are some cases like in Mumbai recently, in my present job. We plan to make a shaft of 70 meters to launch a machine at one go, but there were some issues with the locals. They were not allowing us to work 24 hours because of noise issues, and there were tree cutting issues, and noise was the job was delayed. So we attempted to launch a machine in a shaft of hardly 25 meters. So in that case, only the main part of the machine, which is called mole, which is the cutter head and shield, it was lowered, and all the backup system was kept on the surface. And then we made the connection of the backup system to the TBM through the wires and hydraulic pipes, and then we drive the machine like that up to 100 meters. Once we go inside 100 meters, then we load the backup system. So there are various ways to launch the machine depending upon the site conditions. Ideally 70 meters, but we can also do in 25 meters.
Okay, nice. So as we see, the metros are mostly in crowded locations, so they have to be constructed they are normally constructed through the arterial roads. So you have, when you make a station, Mr. Srinivas, so when you make a station, how do you go about making a station? You have to make an excavation, go down some 20 meters. How do you take care that in your design itself, how do you take care that the neighboring structures are not affected? Can you throw some light on that, Srinivas ji?
Sure, sir. You see, basically everything starts box down from the alignment part. You see, the stations are picked based on the footfall number of people boarding the train and all. Revenues are important for the project, right? So the stations are already finalized. The sketches are already done. So in order to proceed with that particular part of the station, what we do is we have this concept called cut and cover concept. Cut and cover, which means we cut open the box in a form of box. We go down, either top down or bottom up. That is another concept that comes again in the cut and cover. So in other words, what we do is when we cut it, it's not that we cut about almost 30 to 40 meters depth. So at that level, what happens is we need to retain the soil, adjacent soil. That is one thing. Maybe ideally, if it is greenfield, it is only soil. But imagine if it is structures there, buildings there, then we need to protect the buildings. There could be utilities, there could be other structures, wells, whatnot, canals, everything. So we do a kind of retaining system temporarily, so that till we reach the bottom of shaft, or alternatively, if it's a bottom up, then it's a different story. But at the end of the day, we need to have a retaining system first, either temporary or permanent. It depends on, again, various other dynamics like soil conditions and local conditions. But retaining system is primarily, that is the important thing. Once the retaining system is designed and defined, set up, we proceed with that. Based on the methodology like top down, we go from top, then slowly we reach it the bottom. Then we start building up the permanent lining from the bottom, base slab, walls, roof slab. Then we close it. After closing, though the people who are there at construction, they may know that something has happened. But if you bring a fresher one, they don't know what has happened. But underneath there is a big box, giant box, catered for millions of people with different escalators, with different entrances.
Okay. Thank you, Srinivas. Now we have started getting questions from the audience. It's a good sign, very good. There are quite a few questions. I will ask, depending on how this progresses, I will ask some questions earlier, some questions later. Questions which have come earlier, I may ask later. Okay. So let us go with one of the questions Annapurni Iyer has asked. In a package metro construction, is it only one TBM that we use, or we could use more than one working for a package? Palwinder Singh ji?
Sorry, actually, it depending on the scope of the works. We are having packages in Chennai where we are planning to deploy 8 TBMs. So minimum as per my experience, it vary from 2 to 8 number. It can be 2, 4, 6 depending upon how much length of tunnel we have to bore, and also it depends upon the schedule mentioned in the contract. So we are using 4 TBM in Delhi Metro, 4 TBM in Patna. We are using 8 TBMs in Chennai, 4 in Bangalore. So it can be any number between 2 to 8.
Nice. There is a similar question from Gauri Krishna, who says, how do you decide on what type of TBMs do you use? How does the geology affect? How does the soil or rock affect the selection of the TBMs?
Sir, actually geology will define everything, what kind of machine we want. And at the same time, it is very difficult to predict the geology because normally a metro stretch is around 4 to 5 kilometers in length. and we are doing tunneling around 20 meter below the ground level. So what is lying in the Mother Earth, nobody can predict up to 100% accuracy. But still we try to get the geological data. Normally some data is given in the tender documents, and at the same time we also do our own investigation. So depending on that, suppose it is a full soil, then the type of machine which is used is called EPBM. It is a earth pressure balance machine. So whenever we are boring a earth, there are chances that the earth will fall. So we have to create some pressure in the chamber. So when it is fully soil, when we know it is a soil, mostly it is 100% soil, the ideal machine is to be EPBM. So so this machine will always keep a pressure in the chamber, so that the soil in front of the machine is under pressure and it is not falling on the machine. At the same time, buildings on the top are safe. Second type of machine, if it is a purely rock, if we know it is a purely rock, then it is called hard rock TBM. So this is a machine in which there is mainly difference in the cutter head. So if you see EPB, the tools are different, because, and if you see a hard rock machine, then we are putting a cutter disc. Also the opening ratio of the cutter head is less, so that we can create more pressure and more force to cut the rock. So in that case, the chances of the falling rock are very less. So we say this is a machine which is working in open mode. That means there is no pressure on the front rock. So this is called a hard rock machine. Another type of machine which we say it is called it is used for mixed geology, when we know that it may be partially rock somewhere, it can be partially soil somewhere. So these type of machines are normally designed as per our judgment upon the approximation, how much rock we are getting, how much soil we are getting. So in that case, the cutter has it designed in such a way that we can manage both. So we can have a scrapers to excavate soil also. We can also have a possibility to change them with a cutter disc. So this kind of machine is called mixed geology machine. And last type of machine, sir, which is called slurry machine, when we are totally uncertain what kind of geology we are going to encounter, and when we are working, we have to work near the sea or below the sea. So these machines work then we call a slurry machine. Here what is happening, the machine is crushing, but we are using bentonite slurry to go in front of the cutter head and bring all the excavated mal through the slurry pumps. So mostly EPB and hard rock, and then and balance we can develop based on our needs. Basically 4 kind of machines are there.
Right, very nice, nicely explained, Palwinder ji. A similar question was asked by Abhijit also, and some other Hemant Jain. Hemant Jain has asked what is the difference between this one shield TBM and Hem Chandra, shield TBM and double shield TBM. How do you, Srinivas, you can explain this, shield TBM and double shield TBM?
Sir, basically when we say the machines, right, we are also mentioning that we are protecting the above ground structures, above ground utilities, whatever it is. So that is because when we say we are protecting it, it's because of the shields. So the shield which is there annexed with the TBM, the cutter head, it protects. It's a thick metal shell, and then that shell is designed in such a way that it takes the overburden, whatever the overburden is there. So parallelly, when we have a single shield, when we say single shield machine, the machine progress, but it's in cycles. Either we excavate and then we do the ring building. So which means you finish one full cycle of excavation, you stop the machine, then within that gap, the span of that, you build the ring, we build the ring within the shield, and as we start mining for the next shield. So what happens is the next cycle starts. So it's a cycle, like ring building, it's mining cycle. It's the same. When we say double shield, right? So in the double shield, parallelly ring building and mining parallelly it continues. So on one hand, I will be building the ring in the behind, because the double shield will act as a kind of what do you call the ramps, thrust pads would be there, which takes the thrust. In ideal case, single shield, the TBM will take the thrust, the machine front shield. Whereas in double shield, we have shields next to the double shield, so that the thrust is shared by it, and the machine moves, showing with the further progress with the front show. So parallel activities takes place. So the time saving part is there. So, but the length and the cost matters, all these things.
Okay, right. So there are quite a number of questions that have cropped up. Very good, this one. So I like to, maybe I'll have to combine few questions together to ask you. So many people have asked differently. as to how do you manage the, because structures are there close by, do you do some analysis to find out what is the impact of this tunneling or station construction on these structures from the modeling point of view? Are you using Plaxis, or how do you do that? Srinivas ji.
Sir, what happens is when we know that we need to build the tunnels and stations, right? The first thing we do is we don't start the works. We first do a building conditional survey. If there are buildings there, then a structural audit would be taken place. If required, again the buildings are categorized safe, unsafe, all this stuff. Then if it is unsafe, the dwellers, the people who are living it, would be told to evacuate. If it is very poorly maintained buildings and we feel that it's, the reason being is this, the status of the buildings is important. Not only buildings, we have utilities like 30-40 years old. We encountered some 100 years old drainages are there built with brick masonry. When we started opening up, they are unsafe, so we have to divert them regardless of its age and these things. So because we can't reinstate those things, so with the upcoming technology, the new things have to become. So these things are all to be studied much before starting commencement of the tunneling for the safety of the residents and the roads. Vehicles would be flying on it, so underneath we don't know what are all the things. So we do a probing kind of thing. Geotechnical investigation would be done, not at every 10 meters, but randomly some 50 meters or 100 meters to get a rough idea that what it is actually. Building condition survey would be carried out. Utility investigations would be carried out. Traffic intensity would be carried out, so that either we take a call to leave, fully stop the traffic, or sometimes occasionally we make the traffic one way and then one way traffic we divert it based on site conditions. Again, it has to be a call taken by cases. You can't generally say that, okay, this is the hard and fast rule. So again, these are all the guidelines or steps to be followed before we progress with the works. And apart from that, of course, the survey part is critical because our alignment matters for us. So these are all the things that is considered, sir.
Thank you, Srinivas ji. Palwinder ji, I will club a few questions from various people. Probably similar questions I'll club. See, they are asking, Abhijit is asking, how do you do tunneling in soft soils and clay soils? So in an interconnected question which has come later on is, how do you control the water table? If it is cohesion-less soil, then water table, and cohesive soils, what happens to water table? Such things, could you explain what you do at site?
Yes, sir. Sir, whenever we are talking about soil and clay and more water, that means we have to use a EPBM machine, because then we need to create a pressure on the front of TBM, so that the things are not falling on the cutter head and on the machine. Because if they start falling, then maybe on the buildings there we will find some effect. So then in such kind of geology, we have to choose a EPBM, and depending upon the water table, our designer calculate how much phase pressure we need to maintain. Because whenever there will be water ingress, it will come with some pressure. So let us say the water will come with a pressure of around 2 bar. That in that case, I will design by machine which can create a ulta pressure of around 3.5 to 4 bar. So that suppose the water is coming at 2 bar, and I am creating a pressure at the face with the help of a compressed air. More than that means water cannot enter in the machine. So when we have a soil and clay, then we have to use a EPBM machine, and also we need to use some conditioning agent like sometimes bentonite and polymers, which will allow the machine to work in such a way that soil cannot enter and jam my cutter head. So it will make a lumps of the soil. So with all these polymers and water pressure and our air pressure, we are able to drill in such kind of situation with a proper EPBM machine, earth pressure balance.
Okay, is there a situation?
As the name suggests, it will always balance the pressure which is coming from the front. So we have to create a opposite pressure from the machine so that things are stable while we cut through with the help of a cutter head.
Okay. Will you need some ground improvement? There is one question which has been asked. Will you need ground improvement in soft clays, or you could go without?
Sir, normally when we launch the machine, at that time we have to be very careful. Suppose if we expect that the geology is weak, and once we launch, at that time when the machine will enter, it will create a maximum pressure while entering, because it has to cut through the diaphragm wall and enter. At that time, sometimes we do the ground conditioning at the where we have to launch the area. Otherwise, once we enter into, then machine can take care. Even if we machine is also having instrument like probe drilling. We can do the probe drilling in front of the machine to see what kind of geology is. We can also do the grouting if required. If we feel that the geology is too weak, then from the shield which Srinivas sir has explained, we are having provision to do the umbrella grouting. I can drill the hole like umbrella, and I can grout. I can do the stabilization of the soil even from inside the machine. So it all depends what kind of geology we are encountering. But a wise man will choose a machine which is having all the things to encounter such kind of risk.
Okay. What happens when you have a low overburden? Suppose there is a river or
overburden. TBM will not work for a low overburden. TBM mean we should have at least a overburden of 18 to we are normally 25 meter below the ground level when we work with the TBM, because otherwise foundation we will fall with the foundations of the building. There are high-rising buildings. So when we have to cut through, we have to see that we are below the foundations of the high-rise buildings. Normally, if you see the top of the TBM tunnel is around 18 to 20 meter below the ground level. That much gap is kept.
Okay. Srinivas ji, can you tell us what type of surveys and investigations do you carry out before going ahead with the construction or during the design phase? This is also a question that has come up.
Sir, primarily building condition survey, that is one survey we carry out. Secondly, the geotechnical geo investigations, and that too by using this Plaxis software. There are a lot of softwares are available. And imagine in one instance where we have in Hutatma recently, we have done drill and blasting with under sensitive heritage building, but we know that they are dilapidated building, they're sensitive, but we can't start at where do we start the blasting at what pace? So we have simulated with certain worst scenario that we took that as a gauge. We know that by doing this, nothing is going to happen. Then we started tweaking as we move, as we progress, balancing, striking a balance between the progress and the safety of the building. So we have to depend on the technology. We have to use the technology for that. And Plaxis softwares, all these softwares are available. Utilities, we have many tools are available, scanners nowadays for diagnosing the utilities. And then geotechnical investigations, we know we take the bore logs, we physically drill them, we pick the samples, then this has been analyzed, sent to labs, we get the reports. So all these parameters are taken into consideration. Not only that, we also check the water quality of the water, groundwater, what is the water table available at that location, and then what is the quality of that water. So all these things are being taken care of before starting of the work, tunneling.
We hear this term ground loss in most of these analysis and designs. Can you explain what does that mean?
Sir, ground loss is basically, let us say I'm standing or sitting in front of a heap of sand, and at the bottom of the part, with my fist, I just disturb a little bit. What happens is the heap starts disturbed, and then surrounding heap also starts coming towards me because of whatever the properties. I'm not going into details of this. So similarly, when we do the tunneling with the machine, we don't know, we are backside of the ground and we are in a dark actually. So we don't know what is happening in the front. So what we do, we simulate it, we see with the worst possible scenarios. See, we predict certain losses. Accordingly, the settlement monitorings, protection of buildings would be analyzed with that ground losses. So definitely there would be ground loss. Let us say I need to excavate some 60 cubic meters example, but definitely we'll take some bulk factors into that. So considering that without impacting, so by these laws, what is the impact that is going to occur on the buildings or the structures? So that has to be analyzed first. And then we need to find a ways to, if it is going beyond the limits or that is going to create some loss to the structure, then we have to find ways to minimize these loss with the technology. So the paramount importance is protecting the building structures and other stuff.
Right. Palwinder ji, so once the tunneling starts, we know that there is going to be some deformation and your diaphragm wall is going to move and that is going to affect the buildings close by. How can you throw some light on the monitoring, instrumentation and monitoring you do for this? This is also one question that has come up.
But sir, we are not supposed to allow the diaphragm wall to move, sir. Then it will be disaster. So
correct.
It cannot happen because whenever we make a diaphragm wall, we are properly supporting it with the studs, and also we are putting that, and also those studs are under pressure so that there is a so that both side diaphragm walls are standing tall. And
Hmm.
wherever we have to enter in the diaphragm wall, normally we are not using the reinforcement. We are the GR material, so that machine is able to cut that. So we have to enter very slowly. And as I said, if we believe that there are chances that we have a loose geology, it is not only while launching, sir. Even when we break through in a station, sometimes while I am breaking through, if I am not I'm not making a proper care, I will make a sinkhole just at the point of TBM launch. Same is happen for the TBM launching also. I will tell one of my experience in our Mumbai Metro side. In Vidhan Bhavan station, we were about to break through with the TBM which was launched from the corporate side. And we were knowing that in that area, the geology is quite weak from our piling data. And unfortunately, there was no place to do the grouting also to stabilize the soil. But then we have created a false RCC block in the station. And we allowed the machine to break through in that inside the station instead of breaking through in the secant pilot or the diaphragm wall.
Okay.
So all this care we have to take. Similarly, while launching, if I know my geology is bound to be weak, so I will take proper care, proper grouting or whatever needs to be done, or I will enter very slowly. So
how do you monitor the buildings close by settlements? Because we see that lot of instruments on the buildings
yes,
are
sir,
kept.
for that we have survey instruments, sir. We are having our survey instrument which can record even settlement up to 1 mm. Even in Mumbai Metro site, at the critical sites, we have put the online monitoring where the settlement instruments were being recorded 24/7. So even 1 mm, if it is a deviating any while going down or even by sidewise, it can record. So our people are always on the job. Our survey and our instrument team is always on the job whenever we are passing through these buildings.
Okay, what about these heritage structures? How do you take care? Because they are especially heritage structures where the deformation is supposed to be extremely low. How do you take care of this during your
heritage structure is a very big topic, sir. As we have done in our Hutatma Chowk station, where in Mumbai Metro we have to build a station just very close to the heritage structure and very old buildings. Sir, before starting the work, even we have supported all the heritage structures. All the as Srinivas sir has said, we have done the building condition survey to record wherever the cracks are there or what is the condition of building. After that, we have supported all the heritage structure wherever we were feeling that once we do the tunnel or blast or make a station, anything can happen. So all that area was recorded with the steel structures and various things, so that nothing happened to them once we bore or once we build a station. Apart from that, instruments were put across all the buildings. And whatever I talked about the online metering 24/7, it was done in that station also. So heritage buildings are to be taken care very properly. And if we are building a station, the limit of the vibration, the limit of the blasting which we do to break the rock, it is also limited. In our case, it was reduced from 5 millimeter per second to 2.5, and we have used some method to encounter that. Anyhow, that is a different subject, but these heritage structure need to be taken care.
Okay.
So normally, it is our experience that once the TBM pass, because it is at it is at minimum 18 to 20 meter below the ground level. If we take proper care, if we pass slowly and during that locations without creating by keeping the RPM of the cutter head under control, also thrust under control, normally buildings are safe. The things are when we have to do a cut and cover or an NATM tunnel with the blasting, then the vibrations pass through and they can have an impact on the buildings. So at that time, it is to be taken care.
Okay, now you said about the speed or the rate at which you are moving. Can you throw some light on if it is hard rock, at what rate you move? If it is soft soil, at what rate the tunneling is done? Any progress per day?
Sir, if we have chosen a proper machine, whether it is hard rock or it is EPM, then it is not. Then speed will not be determined by the TBM. In my experience, it will be determined by how much muck we can remove. Because we are working in a metro city, once the TBM start mucking, start boring, hell a lot of muck will come. So we have to transport. So if you see doing 10 to 12 meter consistently in a day is possible in both the cases. Suppose we have a soil, it is quite easy, because then machine will simply cut. Like in Ahmedabad, there was no water, it was like a butter. Machine is just rotating the cut head, machine is moving forward. But in hard rock machine, if it is there is no water, and it is a and it is a rock which is not it is a uniform rock, then we can even cut at the rate of 10 to 12 meter per day. But in that case, the cutter disc will wear out after some time, and we have to go for the interventions to change the cutter disc. Only that is the activity which is not happening in the soil cutting. That is the difference.
Okay. Right.
But if we have cases where there is a mixed geology, then there is a trouble. Then there is a trouble. I am only talking about both the conditions where we have a perfectly soil or perfectly hard.
Right. Srinivas ji, like cities like Bangalore, you have large variation in rock, the weathered rock, and within few meters you will find hard rock, and then there is no rock at all. In such cases, does geotechnical investigation identify this and you decide your TBM accordingly, or how do you go about?
Sir, regardless of selection of machine, the geodata is very much required, sir. The reasons are, first thing is, they help us not only for tunneling part, but to ensure that the adjacent buildings are taken care at that particular, let us say a particular location as a rock strata, maybe grade 1 basalt or grade 2 basalt, which is more than maybe 60, 70 MPa. So we ensure that definitely the buildings are safe there. Let us say in the same stretch, there are soft ground conditions. Same distance away from the, let us say, center line of the tunnel for a distance of X in a rock condition, for a distance of same X in a soil condition. Definitely we have to take more protective measures in a soil than the rock. So it is very much required. That is one thing. Second thing is, for grouting, we need to do the annulus grouting as we progress with the machine. So the amount of grout to be pumped. See, when we are at the soil, it is not only the soil that comes in. As we said that there will be loss of volume losses. So whereas in rocks, if it is grade 1 basalt, perfectly we can cut like a cake with the machine to the required diameter. There won't be, unless there are faults and dikes, otherwise very chances of spallings would be very little. You can go through smoothly, and then whatever desired quantity can be excavated. Whereas in soils, it is not the case. So always we play some safety factor to protect the surrounding buildings, and then grouting it, enormous grouting with a grouting pressure. The pressure is another important aspect. At that particular location, what is the hydrostatic pressure available, so that we need to pump against that pressure, the grouting. So then only we can stabilize the tunnel and the linings for a certain period of time. So this is required, sir. It is pretty much required. Regardless, okay, machine choice, choosing the machine is one aspect of it, but the other aspects also, as what I mentioned, that there are these things that comes into picture.
Nice, very nice. Palwinder ji, what I wanted to ask was, what is this intervention? Many times we talk about intervention. When is it done? Why is it done? Can you explain that?
Sir, as we are talking about the tunnel boring, that means we have to cut the soil or rock. So every cutter head will have some tools. So in case of the soil, there are simple scrapers. But if you see hard rock, then we have cutter discs which are very heavy, weighing around 100 kg each cutter disc. So normally if you see a hard rock machine or a mixed phase machine, it will have around 42 to 42 cutter discs. So these cutter discs, now we are cutting the machine with the cutter head, and once we cut the rock, these discs will wear out. So once they wear out, the machine will not move. So we have to replace the cutter disc. Now to replacing that cutter disc is called intervention. That no, we are intervening in the machine in the cutter chamber to change the cutter disc. And every machine is designed in such a way that from the back side of the cutter head we can change the cutter disc. Anyhow, we can move the machine a little bit behind, but nobody is expected to go in the front of the cutter head between the soil and cutter head to change that cutter disc. So we are changing the cutter disc from the inside of the machine. So this is called intervention. So and also there are cases. This is in the normal case, sir. But there are also cases where we are encountering a lot of water, or the geology is weak. Then we have to always keep a pressure in the cutter chamber, in the compressed air. In that case, even in that, when the cutter head chamber is charged up to 3 to 4 bar, even in those conditions, people go inside in that cutter head chamber. They are very special people. They are having we have all the medical fitness is checked. In this pressurized chamber also, they go and change the cutter disc.
Oh, so that's a risky job.
Risky mean we need a different kind of people. Tunneling is a risky job, but we have to manage a risk. Every tunnel is having his own risk. But those people are quite different. After they change the characteristics, they have to be taken out. Then we need to decompress them. Then we have a decompressed chambers where they are put down for the treatment. So all these things we have to encounter once we do the tunneling with the TBM.
Okay, nice. Srinivas ji, when is NATM used? NATM, as you all mentioned, it is like drill and blast or manually done methods. Under what conditions is NATM done?
Sir, basically the name NATM is coined from Austria. It's a new Austrian tunneling method. So basically when this was invented, the purpose was it's a soft ground soil. So the soft ground soil, when we excavate progressively, it is also called SCL, sprayed concrete lining in UK. There are different jargons in different countries, but the fundamental concept is same, sir. In a soft soils, usually, if we progress it, we have to go by stages like heading, benching, and invert. The reason is we excavate heading in an arch form, which is self-supportive temporarily for certain period. We do shotcrete immediately, initial layer, so that that arch is protected for certain time. Then we go for the wire mesh and lattice girders for second layer after certain layer. That is heading part. Once we go for, let us say, 4 meters of heading, then we come to the first 0 to 2 meters of benching part, 2.5 meters, let me say that. So once the benching is stabilized and safe and secure, then I go for invert from 0 to 1 meter. So this is how I progressively proceed with the tunneling work slowly and cautiously. So this is
But is it applicable for underground metros within cities?
Sir, if it is soft ground, yes. But if it is, let us say, fortunately, if it is a grade 1 basalt, so you need not go with these stage-wise constructions. You can straight away start blastings. If it is a green field, then full phase blasting of required size and diameter can be done. Let us say you are underneath the buildings. Then again, though it is not heading, benching, and invert, but the problem comes is what is the overburden above the tunnel crown to the building bottom. Based on that, the top portion would be excavated or blasted very carefully so that the vibrations passing through that overburden doesn't impact any risk to the buildings. Whereas at the invert, which is far from the overburden, yes, we can take a little more risk for progressing to compensate the progress loss. So usually this is the strategy we adopted. Basically, it's an art actually. Somebody said the tunneling is an art. So it's as we move, as we progress, we have to play with that. So NATM is kind of these things. So once the primary lining is finished to the required size, shape, the beauty of NATM is in case of tunneling, we have fixed sizes, either circular or nowadays we have rectangular machines. But let us say you want to have an R-shaped tunnel or a oval shaped. So these things are not possible with the machine or made to order. These machines to be made and then there could be, we don't know. But whereas in NATM, yes, you get the required profile to the shape, size, everything. But at certain risks and certain costs and certain delays. But this is the beauty of NATM. And where it is used, it is, let us say in one of our line 3, we have cut and cover part, but half of the cut and cover station is with a cut and cover, half it is NATM, and the remaining part is bore tunnel. We have used 3 types of tunnels to meet the demand there. So
even the cross passage will be a NATM tunnel.
So cross passage is connecting the 2 tubes, right? The length is very little between the 2 tunnels. At the best, you can say 1 diameter or 1.5, 2D, right? If you speak about 6 meters diameter, the distance between 2 tunnels would be 12 meters. So when we say 12 meters, we cannot use any machinery which fits into the 6 meters of tunnel. Then use this cross passages is just for the people to pass. So which means ideally NFPA says that 2.1 meter by 1.2 meters the minimum size required for a shutter to. But usually we have other utilities coming, so we make a little bit bigger. So for that we don't have that much machinery to install to mark out. So usually we adopt NATM technique manually. Initially, slowly conquering the length little by little bit.
Okay. I think we are nearing to the closure. So let me ask Palwinder ji one question. What is the greatest challenge or difficulty that you have faced in any of these projects?
Sir, I will share about this Mumbai Metro job only, where Rao sir was also along with me. Sorry, sir, this was regarding building a station in Hutatma Chowk, as we discussed about the heritage buildings. Sir, actually in that station there was a narrow road, so we cannot even make the full station by cut and cover. So half of the station was built by cut and cover. That was only upline, and to make that downline, we were supposed to enter via cross passages, and then make a NATM tunnel, which will be the part of station around 260 meter length and around 11 meter of dia. And sir, on the above of NATM tunnel, there were all heritage and very old buildings. And the condition of buildings were so bad that BMC has already given instruction to demolish the buildings. But they were not breaking it, because if they break one building, all the buildings were supposed to fall. So this was a condition on the top, and we were supposed to make a NATM tunnel with the drilling and blast. And as per contract, our vibration limit was 5 millimeter per second, but High Court has given the directions after seeing the condition of building, you make it 2.5. And none of us was at that time, neither L&T or GC or MMRC, they were confident that we can do it. So, sir, then we hired one expert, and he suggested that one material is available in South Africa. If you bring that material, it will blast, but there will be no vibrations. So then we contacted that agency and asked some material for the trial. But he told, no, it cannot come. You have to buy a full container, otherwise he cannot give. So we thought something is fishy. Then I asked him to create a trial site at South Africa. Then I went to South Africa and we did a trial there. And when we did a trial, the rock was broken, but the vibration went up to 22 millimeter per second.
Oh my God.
So our garment was 2.5.
Oh.
So then the next solution was to do the mechanical tunneling with the help of a road address. Whatever we did in Subansari, and we have some 8-9 machines available in L&T, but those machines are not in working order. When we asked our internal department, they told they cannot be made ready as per your schedule. So then I tried to bring a road header from Germany, but at the same time the COVID struck. So that was also ruled out. Then there was no option available, and we were simply thinking whether this will happen or not. Even people were talking that we may have to leave the station just like that. So then we developed our own in-house method. Srinivas sir is aware. So we use a combination of the drum cutter. It is a smaller version of road header, and line drilling, and our own in-house designed blasting patterns with a longer delays, so that when we blast, the vibration are not going beyond 2.5. And we opened multiple front, and still we were able to complete the station in a reasonable amount of time, which is fitting our time schedule. That is the biggest risk and achievement, I will say, in my life.
So when you did that blasting, what was your PPV?
Sir, it was never gone beyond 2.5. Average was 1.8 to 2.1, 2.2.
Okay, so controlled blasting really helped them.
Controlled blasting with the longer delays, and small blast. I had only 8 to 10 blasts at one location at a time.
Oh, very nice.
Yes.
Right, we'll take a last question. Srinivas ji, what is your experience? Any
challenges, sir?
Challenges, yes.
Yeah, I just share a few basic challenges, because most of the people you mentioned are students, so they will understand very easily these things rather than going into much depth with, because there are many challenges, but most of the people doesn't understand unless they works on TBM. But I just share a few simple things. In Chennai, what happened? There is a question also. One guy, I just going through the chat box. So he asked, any sinkholes happened? I don't remember the name, but sinkholes has happened. Yes, it has happened. Why it happened? Actually, before launching the machine, we do all risks analysis, sir. We take all risks, including sinkhole. Yes, sinkholes. We don't allow any sinkholes, but we have to face the fact that this might happen due to various factors, unforeseen ground conditions, because we don't do bore locks at every inch by inch or meter by meter. We do it to 150 meters, 100 meters. So from 0 meter to 100 meter, anything can happen in between. So these risk factors, to mitigate these risks, we analyze all the sinkholes under it. What happened is in Chennai, we have a ground settlement markers placed on the road. We every day monitor it. There are no visible settlements visible. No adjacent buildings are there, safe. Muck condition is very theoretical volume. We are able to excavate desired volumes and all. Once suddenly it so happened that there was a sinkhole. So after investigation, it is encountered that the overlay underneath the road, it is getting caved underneath the road. But because the overlay of the asphalt, people usually they should scrape it off when a new overlay has been laid. But that didn't took place. The overburden of that asphalt itself was a half a meter thick. So this half a meter thick old asphalt is taking the load, though there was a cave underneath. So one fine day, as the days pass by, the readings are zero because no signs of settlement errors. So as an engineer, I think that everything is safe because my buck volume is matching to my, and the tunneling speed is matching to my requirement, design requirements, everything. Grout volume pumping is going only to the required volume. So I thought it is a safe thing. But suddenly one fine day, there's a sinkhole. So what happened is, there was a ground going in, ground loss happening underneath this half a meter thick, but it took time for this half a meter asphalt to behave, and suddenly already the caving happened already. So it took time to settle it. So by the time, suddenly, usually we have these trigger values for settlements, right? Alert, action, that didn't happen. From zero, boom, all of a sudden it was suddenly.
This was on the Punamali High Road, no?
Yeah, yes, sir, exactly.
Correct.
Exactly.
And this
So
question was raised by Hem Chandra.
Yeah. So this is what it's a real and then one in Doha, sir, simple case study where the alignment is very near to the seashore, and then there was one abandoned park in Doha. This park was, it was actually a kind of a mini valley, and it was filled with the soil to make it a park. They reclamated that park, and then they made it a park, that valley. So but they dumped the boulders and all. There was a passage of sea link to that. When the machine was passing through that, one of the boulders stuck through the machine conveyor, the screw conveyor, the door, we could not close it. By the time we made efforts to close it, the sea took over the control of this and then started flooding in. And then people has to be evacuated. So this is another challenge. Even Mumbai Metro recently, the buildings, we don't have historical data of these buildings, what kind of structures they are built on, what sort of foundation they have. We went all sort of NDT tests, UPV, Schmidt-Hammer test, whatnot, you name it, all sort of tests. Then we have to come to a conclusion based on the assessments derived from these individual tests, and then a worst scenario was adopted to protect these buildings. So there wasn't any data. 90% of the buildings doesn't have any historical data. When they were built, what sort of foundations they were, what depth the foundations were. So before starting the tunneling of these. So these were a few challenges where most of the fresh engineers can easily understand it, sir.
Yeah, very interesting. I think we have come to the closure. We just have some few minutes left. So we've had a very good discussion. I am sure that the audience would appreciate that they could get a lot of insight into underground metro construction. There were a lot of questions. The number of questions raised till now were 46. However, there are questions which are very, very technical in nature, something related to Plaxis and something related to specific geology. I think we would not be able to take that because it becomes too specific. And I'm sure others, we have tried to cover all the areas in underground metro, NATM tunneling, PBM, then cut and cover. So whatever we could think of, and most important, we have covered, I think. And Palwinder Singh and Srinivas ji have tried to explain things as easy and as vocal and as possible to make this very interesting. I'm really thankful to both of you for sparing your time in explaining all this to our people. Thanks a lot. And I thank DFI also to have given this opportunity to have this panel discussion on such an interesting topic. Thank you, DFI, for this.
So thanks for the opportunity, sir. Thanks to all the participants for patiently listening to us.
Thank you so much.
And thanks again for this opportunity.
Thank you very much.
Yeah.
It's our pleasure.
Yeah, Pranav, you can take over.
Thank you. Thank you so much, Pitchumani sir, for coordinating today's session.
Thank you.
We also thank. Can you hear me now, sir?
Yeah, we can hear you now.
Yeah. So thank you so much, our panelists, Mr. Palwinder Singh and Mr. Srinivas, for such an interesting and engaging session. So just to brief you all regarding the upcoming groundwork session, this Groundwork 2023 series will resume after DFI India 2023 conference, that is in November. You can follow our LinkedIn page for regular updates. And also, as most of you are aware, DFI of India is conducting its 12th annual conference during 5th to 7th October 23. So several national and international experts from renowned organizations are delivering keynote presentations during the conference. So we encourage you all to register for the conference. And the very highlights of the conference include keynote presentations, special session on the theme Deep Excavations, and Women in Deep Foundations program, contributory paper presentations, exhibition by top Indian and international organizations, networking, Lifetime Contribution Award, Best Paper Award, DFII Student Awards, and an optional chance to visit Statue of Unity. And the sponsorship opportunities are open. To sponsor, you can contact DFI of India office. And to know more information about the conference, you can visit conference website. So this marks the end of today's session. Once again, thank you all for attending today's session. We hope to meet you all at DFI India 2023 12th Annual Conference at Vadodara during 5th to 7th October 23. Thank you.
Thank you.